Let's take a look at how we use the mean and the standard deviation for a normal distribution. This will bring us back to the question we asked at the end of 3.2 about the number of customers at a particular business using a particular probability distribution. So the mean and standard deviation of a normal distribution are actually the parameters for that distribution. What does that mean? That means all you have to do is say a random variable is normal with mean blah and standard deviation blah, and you know everything you need to know about it. So in the example we were looking at in 3.2, we were looking at a random variable. It was a binomial random variable which represented the number of weeks in which we had at least 300 customers over the course of a year. So this took on values from 0 to 52. This is because 300 is our break-even point. And we saw how, because we have so many trials, 52, that the distribution was approximately normal. Well, using that distribution, I went ahead, I'm not going to ask you to do this, but I went ahead and calculated the mean and normal and standard deviation of the original binomial probability distribution for this random variable. And that's what we use for the mean and standard deviation of the of its approximation with a normal distribution. The mean was 23.4 and the standard deviation was 3.59. What does that mean? That means we expect, on average in a given year, that we'll have more than 300 customers 23.4 of the 52 weeks. And that most of the time we'll have between roughly 20 and 27. That is 23.4 plus or minus 3.59 weeks. So it's roughly 20 to 27 weeks in a given year with 300 or more customers. What do I mean by most? Well, we can actually say this very precisely with a normal distribution. 68% of the time, we expect our outcome to fall within one standard deviation of the expected value, somewhere between one below, standard deviation below on the left side, to one standard deviation above on the right side. Anyhow, we might want to ask a question such as, what's the probability that we have less than 30 weeks with at least 300 customers? Let's say our break-even point requires us to have at least 30 weeks with 300 or more customers. What's the probability that this does not occur? That is, that we have fewer than 30 weeks with at least 300 customers. Well, as said before, we go to the tables, the normal distribution tables. However, this sample table is over here on the right. The problem we have is that this tables assume we are using a standard normal distribution. The standard normal distribution has expected value 0 and standard deviation 1. So that's not going to work because our standard expected value is 23.4 and standard deviation is 3.59. So what do? We do something called standardize the random variable. So the probability, if x is our random variable, which is the number of weeks with 300 or more customers, the probability that that is less than 30 is equivalent to the probability that something called z is less than 30 minus the expected value divided by the standard deviation. Z is a standard normal random variable. This allows us to use our table. What we're doing is we're taking the number that we're interested in, which is 30, and we're subtracting the expected value and dividing the difference by the standard deviation. This measures how many standard deviations away from the expected value the number 30, which we are interested in, falls. This is called standardizing the random variable. Using our figures from this example, we subtract the expected value, 23.4, from 30, divide by 3.59, and we get approximately 1.84. Most of the tables don't go beyond 2 decimals, so 2 decimal places suffice. So put in probability language, the probability that our random variable, the number of weeks, is less than 30 is equal to the probability that a standard normal random variable is less than 1.84. 1.84 standard deviations from the mean. We can now take this number and go to the standard normal table. This is an example of a standard normal distribution table. Often we use symmetry and other rules in order to get anything we want, but we're just going to do this one simple lookup. So what we have here are positive values of z. Remember, that's our standard normal random variable. And in the table, all these 4 decimal numbers are probabilities. So if I go to this number here that I'm highlighting, this is the probability that z is less than 0.42. So these are the whole part in the first decimal place, down the rows, and across the columns are our second decimal place. We wanted to know the probability that z is less than 1.84. So we start with 1.8. Here's 1.8. This entire row has the probabilities for 1.8 blah. Well, we wanted 1.84, so that means we need to look down the column where we have the second decimal point being 4. And we see where they meet right here, 0.9671. That means the probability that our standardized normal random variable is less than 1.84 is 0.9671. Put differently, the probability that the number of weeks is less than 1.84 standard deviations of the expected value is 96.71%. So let's go back and take that number and use it to make sense of our problem. So we were asking, what's the probability that the number of weeks with 300 or more customers was less than 30? We standardized this by subtracting the expected value and dividing by the standard deviation, and found that that was equivalent to the probability of a standard normal random variable being less than 1.84. And we went to the tables and we got the value 0.9671. So there's a 96.71% probability that fewer than 30 weeks will have at least 300 customers. So now we want to know what's the probability. What we really want to know is what's the probability that we will have at least 300 customers for 30 or more weeks given the year. We found the opposite, so we use this complement rule and subtract from 1, and the answer is 0.0329. So that means the probability that we will have more than 30 weeks with 300 or more customers is 3.29%. If that's what you need to break even, you need to do a little bit of work to bring down your cost structure still in order to increase the profitability of your firm. In the next several sections, we're going to look at something called conditional probabilities. What if you know some of the things you need to know in order to figure out the probability that a random variable takes on certain values? For example, let's say you know you'll have at least 100 customers every single week. Then what's the probability that you'll have 30 or more weeks with at least 300 customers? That's called conditional probability, and that's what we turn to next.